So this is the solution. So this is exercise 7.1. And just wanted to reiterate some things here. So these exercises that you're going to do in here, they typically follow a pattern. I've discussed this pattern before. Typically, you're going to start with your variable declarations. Okay, it's standard to declare your variables up top like that. I mean, I know you can declare them in other places, but it's standard to do it like that. So that's a good place to do it. It's nice to have all your variables in one place. At least that's the way most people prefer it. So we do variable declarations, and then we do input. We're going to get input from the user. Okay, so we have our input section, and then we're going to do some calculations, and then we're going to output some stuff. So those four things, those are very typical in all the programs you do in here. So remember that when you're trying to solve something. So, you know, first, obviously, before you can use a variable, you have to declare it, and you also have to put something in it. So, like in this line right here, what I'm doing is I'm asking the user, I'm prompting them for the radius of a circle. And of course, again, we've discussed that I typically use right to do prompting, okay? So that what the user types appears on the same line after the colon. But then I'm grabbing from the console, I'm grabbing a value and putting it in radius. And of course, I'm converting it to a double first, because why? In this case, I'm converting to a double because
So you can get a decimal.
well, so I can get a floating point value, yeah, so I can have a decimal point, a floating point value. But read line returns a string, so I got to convert it into a number, so I can put it in radius, which actually is a double. So radius is a double. So I have to make sure that what appears leftmost here is converting this to a double, right? Notice how that appears on the left. So this is the last thing it's done, is converting to a double. So console read line reads something in as a string, and then we convert it into a double and put it inside radius. Okay? So hopefully everybody's getting that by this point. So next, we want to do some calculations. Before we can do the calculations, though, we have to grab values. We have to put values in some boxes before we can do certain calculations. So for instance, to calculate diameter, I have to know radius first before I can calculate diameter, okay? Because the diameter is radius times 2. So I have to know the radius first. That's why I grab it up here first, okay? So at that point, radius has something in it, so now I can figure out the diameter. Likewise, to calculate circumference, I need to know diameter first. So I make sure I calculate circumference after I've already figured out the diameter. You see how that flows right there? So now I can use diameter here once I have it figured out up here. So it's important that I fill diameter with a value first before I use it to calculate circumference. Okay? So put things in those variables before you use them for calculations. It's important you get that order right. Like for instance, I wouldn't want to calculate circumference, try to calculate circumference. I wouldn't want to switch these around. I've seen that. I've seen people try and do that. It won't work because diameter doesn't have anything in it yet. Okay? Let's see. And then finally, let's see, output. I guess that doesn't need any explanation. Don't forget about, you know, the format specifier, F, I can use for floating point values to control the number of decimal places, so 2 would indicate 2. Okay? Any questions about that one? So this is, you know, my solutions are how I would, well, they're actually how I would do it for this class at your stage. Sometimes I would do things a little bit more, well, professionally, but right now I'm doing them in a way that's easier for you to understand as you're starting out. So this is typically how, these solutions are how I would typically do these problems myself. All right, so that was 7.2, or 7.1, excuse me. And let's see, this one, 7, good God, I can't see that. So exercise 7.2, there's nothing, you know, big there, except that I did use, this time I used, well, let's see, in the last one I used math.py, didn't I? Yeah, so instead of writing out pi yourself, just go ahead and use math.py. It's a lot more accurate, okay? And nothing else there needs explanation, I don't think, except perhaps the division. Diameter is what data type? a double, and I'm dividing it by what data type? An integer, which gives me what? Gives me a double. So a double divided by an integer still gives me a double. So I don't have to worry about floating point division or anything like that in this case, right? So I could write that as 2.0, but I don't have to. It still comes out right. Remember, integer versus floating point zero, or floating point division. Integer division versus floating point division. That's a big topic. Is there any questions on that one?
If we put 2.0, would it like mess anything up, or would it just
Nope.
make sense?
No, in this case it won't. It doesn't make any difference. You can write it either way. For me, I prefer to write it just 2. It just looks nicer that way.
And just to like recap, if you do the integer instead of double, it would round to the nearest number if you divide.
No, if you do integer division, it's only going to give you the quotient from the division.
Okay.
So it's not going to do any rounding. Yeah. Yep, that's it. So it's just going to chop off. It's going to chop off the point and everything behind it. It's going to truncate it. And we'll see an example, I think, in a second here. Let's see, this one where I'm getting the triangle area. All right, so again, I'm just reading some stuff in, converting to doubles, reading some values in. Notice again, it's following that pattern. So I'm doing variable declarations, input, calculations, and output. Let's see, for the units, enter units. Now, so I didn't do any conversion here. Why not?
Is there going to be a string anyway?
Yeah, because units is a string. Read line returns a string. Okay, but let's see, wait a minute. Let me do this. So if I had done this, any problem with that? It's just unnecessary, right? We don't need to do it. So I'm taking something that's already a string and converting it into a string, which it already is. It doesn't, it's just unnecessary. But it'll still work. C# will still do it. All right, so I see that a lot too. I see people converting strings like that. But since units is a string, we don't have to convert anything. Okay? Now for the calculation, I kind of cheated on this. I guess I wasn't thinking when I did this. I wrote 0.5. The formula is 1/2, okay? But it's easy enough just to write 0.5. Again, if you wrote let's just do it. Okay? Anything wrong with that?
Yes.
Yes, what?
That floating point.
That is integer, but you want a floating point, right? So this is integer division. So it's going to give you, what's it going to give you?
It's going to give you the quotient, but not the decimal.
And in this case, the quotient is going to be 0,
Yeah.
right? It's going to be 0, so everything, the area is always going to be 0. Everybody understand that? Okay? So if I wanted to do it, I could do 1.0. That would force floating point division. So then it would come out right. Or I could also do this if you want to make it even it out. Whatever, so long as one of them has a 0.0. That makes it floating point division, okay? And then that's just standard using string interpolation. We print out the area and also whatever units the user entered. Now notice up here I told the user to enter in inches, feet, or meters. What if they entered yards or miles or? Yeah, it wouldn't matter. It would still print out whatever they typed because we don't have anything to check to make sure they entered what we asked them to. We actually know a little bit. I mean, using logical operators, we could test to make sure. But later on, when we learn more advanced concepts, we'll see easier ways to check user input and make sure it's what we want. But right now, whatever they type, they could type New York, and it'll print out New York right here for units instead. C# just does what it's told. It doesn't know any better. So any questions about that one? Now here's one. Oh yeah, this is good. So right here, you know, I'm calculating Fahrenheit. And since Celsius appears in front, so remember the order of operations is going to do multiplication and division first, and then subtraction, addition after that, and it's going to go left to right. So it's going to scan this expression left to right, looking for multiplication, division first, and then it'll do addition and subtraction. Well, Celsius is a double, right? So if I do a double times an integer, I get a double, right? And then a double divided by an integer would give me a double. Technically, I don't have to write point zeros here, all right? Because it's gonna, even though by itself this would be, actually let me, probably more clear if I actually write it. All right, so if I wrote that, the answer will still come out correctly because double times integer gives me a double, and then double divided by 5 is going to give me a double still. So it'll still be doing floating point division. Even though by itself, you see 9 by 5, if that were done by itself, in other words, like if we did this, we could force it to do, so what about that now?
It would be integer division.
It would be integer division, and it would give me the wrong answer, okay? Because I'm forcing it to do 9 divided by 5 by itself. All right, but if I do it this way, it's going to go left to right. It's going to do Celsius times 9 first, so I'll have a double, and the answer will come out correctly, okay? So again, it's just more about understanding that floating point versus integer division. But I wrote it like this anyway. I mean, technically it doesn't matter. Everybody see that? Anybody have any questions or problems with it? Oops, that's supposed to be lowercase. All right, anything else? All right, there's nothing else very revelatory in that. See the grades. This one's interesting. All right, so the grade averaging, okay? Now, I think most, maybe all people, I don't remember for sure, but most people declared, so we had to enter 10 grades, and so most people declared 10 different variables for that, which is understandable, and technically nothing wrong with that. It's just not the most efficient way, because like, what if we want to expand it to have it enter, allow for 100 grades to be entered? Then you're declaring 100 different variables for every different grade that's entered. Okay, so it just gets crazy and inefficient. So what we can do is, so I've declared a total of 3 variables here. So I got one for the current grade being entered, okay, and then I got one for a running total, grade total, and then finally one for average. Now, what a lot of people did was they came down here for the calculation and just added all the grades together. They summed them all together at the end, okay, which is fine. But there's nothing that says we can't sum them together as we go. So we do a running total, and then instead just take that running total and divide by 10 at the end. So a running total instead of adding all the grades right there in that spot and then dividing by 10. All right? So what I do is, so I go up here and prompt for grade 1, read it in to current grade, and then grade total becomes, so I'm using that plus equal, okay, that shortcut assignment operator. So plus equal means grade total becomes its current value plus current grade. So the current value of grade total is what at this point?
Whatever you enter.
Actually, the current value is 0. So I got it initialized to 0 up here because I don't have a total at that point. So I initialize it to 0. So when I add 0 to current grade, it's going to give me, so grade total becomes whatever that current grade is, okay? And then the next line, it just repeats. We just keep repeating the same pattern over and over again. So we read in current grade, and we say grade total becomes whatever it was we calculated up here, plus this new grade, right? And so we keep adding as we go along. Everybody understand that?
And we would do that for every single one, even if it was like 100 of them?
Yes, all you would have to do is just copy and paste these lines here. You don't have to create any more variables. Just keep copying and pasting those lines. And you also have to change the grade number too, but I'll show you a trick for that in a second as well.
Would it be possible to set it up a way where you wouldn't have to copy and paste it, and you could input each one in one string?
Yeah, actually when we get to loops, which is the next thing we're going to do, we're just going to have one set of these lines, and we'll just loop as many times as we want to enter grades. So if we want to have 100 grades, we'll loop 100 times. We want 10 grades, we'll loop 10 times. So yeah, this is definitely not the way to do this, but we haven't covered loops yet, so we don't know better yet. So this is the way we do it at this point. But yeah, just keep on copying those lines. So calculate the average, and then print out, and that's pretty much it. Okay. Any other questions about this one? I'm going to show you a much better way to do this in a second. Man. All right, so in this version, it's a little bit more efficient and streamlined. So this time what I do is, let me bump up my view. So I create a variable called grade index, and I initialize it to 0. I'm going to use grade index to keep track of my current grade number. In other words, am I entering grade 1, grade 2, grade 3, what? All right, so that's what that's going to do. Again, I'm going to have grade total set to 0 to begin with. Same thing as it was in the last version, and average is also the same, no difference there. So we come down, first thing I'm going to do is I'm going to increment grade index. So remember, plus plus, that's pre-increment. That means take grade index, add 1 to it. Okay? Now, so that's going to make it 1. Now, in case you're wondering, yes, I could have just initialized it up here to 1 and just wipe this line out. But what I want to show you is a pattern that I'm creating here. Okay? So increment it to 1. Now, I'm going to, in this right, I've adjusted it slightly. So using string interpolation, so it's going to print out grade, but then it's going to grab the value in grade index right above my cursor here. So it's gonna put 1 there. It's gonna print out 1 there. All right. So the great thing about that is I don't have to put the number in anymore. In the last version, I hard coded the number. Okay. But here it's gonna automatically figure out what grade number I'm on and print it out for me. All right. Next, with the grade total line, I basically just combined it and made it all one line. I like it like this much better. But it works out basically, it works out the same as previously, but I was able to get rid of current grade, so I was able to lose that variable is one thing. So just read in the value, convert it to a double, and then add it to grade total. So I'm still using plus equal. So grade total becomes its current value plus whatever we're reading in right here. Okay? Now, all we do is repeat the pattern. So there it is, those 3 lines. Again, every time I add a new group, it's going to automatically print out the correct grade number for me. I don't have to change anything. I just keep copying and pasting all I want. And that's really all the difference there. But like this right here, that's probably something, you didn't think of, that you could do. I don't think anybody did anything like that, but yeah, little tricks you learn as you go. I mean, things like that are handy. Anybody have any questions about it?
Would you have to copy and paste the new set of lines for every time you want to?
Yep. Every grade you want to, like if you want to have it so you can enter 200 grades, yeah, you'd have to copy and paste that same 3 set every time. But you don't have to change anything. It's nice.
So if you want to go from 10 to 20, you could just copy 10 and then double it.
Exactly. Yeah. You don't have to edit your code. Yeah. So again, yeah, when we get to loops, it's going to be nice. We just put all this in a loop, and that's really the way to do it. But anyway, any other questions? Any questions about the math class? So math square root, I had that in my notes. I also had math.pow. So we could calculate powers. So there's math.pow, you give it a base, you give it an exponent. Now, just so you know, you can go out to Microsoft's website. There's all kinds of useful stuff out here. Everything you want to know about the math class, you know, it's here. I gave you a link to that in my notes as well. But you can go down and methods, that's what you're looking for. You know, and notice there's pi, okay? That's what we call a constant, and that's why it's off by itself. Don't worry about E. But all these methods available, you want to find the absolute value of something. If you want to find, let's see, let's go to, well, max. How about max? So we want to find the maximum value between two. So I have the worst time seeing up there. All right, so here's max. Notice how many versions of max there are. So these are what are called overloaded methods. We'll learn about that in the next course. But anyway, the one that you're probably more interested in will be max double double, and also int32, int32. So int32 just means it takes integers. That's all. It takes 2 integers. Double double means it takes 2 doubles. Okay, so you give it 2 doubles, and it compares them and returns a value. But anyway, so, and that's pretty much all you got to know about these things. But you see all kinds of advanced mathematical operations are in here. You can round things, figure out powers, all kinds of stuff. So don't be afraid to look in there and find things that you might want to use. And let's see. Oh yeah, this is good stuff. All right, how about this one? Now this is one of the examples in the current assignment. So what are we doing here? We are figuring out even odd. So, you know, again, declare variables, get user input. So this time I'm doing integers. And I'm doing integers, why? I'm figuring out even odd. And for that, I have to use the mod operator. And mod operator only works with integers. I can't use it on floating point values. Okay, so that's why I declared user input to be a integer. Okay, so right in here, that's this condition right here. That's what's key. User input mod 2. If it's equal to 0, then the number's even. Okay. I've already shown you how to do this. If you do longhand division, take any even number, or any number that's even, divided by 2, the remainder is going to be 0. So I can test for that. So if I mod a number by 2 and the result is 0, I know it's even, okay? Now, the only other thing it can be is odd, so I don't have to test for that. I just use an else, okay? I could do another test here, but there's no reason to test. If I already figured out it's not even, the only other thing can be is odd. All right? Any problem with that? Any question about it? Now let's do this. Now we said with odd, if a number's odd and we mod it by 2, what do we get? We get what? Well, we do get a remainder, but 1 or negative 1 if it's a negative number. So if it's a negative even number, we're still going to get 0. So if the number's even, if it doesn't matter if it's negative or positive, we're going to get 0. But if a number's odd, we're going to get 1 or negative 1. So that's why it's easier to test for even. Because here's what we have to do for odd. We have to do something like this using our logical operators. So this says if the number mod 2 is returns 1, or if it returns negative 1, it's odd. So we have to use that logical operator, that logical OR. Everybody remember that? So OR says that if one or both of these things are true, then we're going to do this. We're going to print out odd. Okay? Otherwise, we can print out even. So see, it's a little bit more efficient to test for even, because with odd, we got to test for 1 or negative 1. Is that clear to everybody? Why is it doing this? Oh, I see why it's doing that, because I've got an assignment operator. That should be equality, okay? Nobody caught that. Yeah, make sure you don't put in the wrong, 2 equals to test for equality, 1 for assignment. I got to fix it in my notes too. Oh well. So any questions about that? Far out. And let's see, we've gone over that before. Positive, negative, neutral. So everybody understands. Everybody comfortable with if else, when to use if, else, when to use else. Just remember, else is the catch-all. Else ifs go in the center. This is nice. Okay, so for this one, I'm testing to see if I've got a valid triangle. So to have a valid triangle, if you add up any 2 sides on the triangle, that value will be greater than the 3rd side. Okay? So if I add up any 2 sides, whatever that results in should be greater than the 3rd. All right, so the first thing I'm going to do is, grab the values for the sides. Okay? So do all those read lines. But here's where the fun comes in. This logic right here. So this right here, this whole thing is the condition for that if. I've got it on 3 separate lines. We could actually put it all on 1 line, but it looks nicer like this, I think. You can do it however you want. C# doesn't care. So notice it's side 1 plus side 2 if that's greater than side 3. Okay? So I'm doing a calculation in here. We can do that. I could have also done it somewhere up here, but I like it like this better. So side 1 plus side 2, if that's greater than the value of side 3, and also, so that's an and, that means what?
Both the conditions have to be met.
Yeah, both sides of it have to be true. In other words, as soon as we see a false, then the whole thing's false. So with and, if there's a false, everything's false. All right, so, but if this is true, and also this is true, and also this is true. So I got 3 things that have to be true in order for it to be a valid triangle. All right? And that makes sense. I mean, if you speak it out in English, it totally makes sense. Anybody have any questions about that? Huh. Anyone? Well, I have a question. Why did I put that $sign there? But I don't need it. It's not necessary. It doesn't hurt anything. I'm not actually grabbing any values out of variables, but anyway. So everybody's cool with that? So, and again, we use else because once we've tested it, it's either valid or it's not valid. So we only have to test one thing. Okay? Oh, let's see. All right, so this one, this is just a ridiculous little program I made. So I'm going to do some, let's see, I'm going to do some string variables, cleaning, X-ray, filling. Again, you could put those all on one line. I like to put them on separate lines usually. So those are all strings. And I'm going to prompt the user, did the patient have a cleaning, Y or N? Now it's important when you really want to let your user know what it is you need them to enter, and especially in this case because I'm asking for, letters, or if you're asking for words or things like that. So here I'm telling them capital Y or capital N, okay, which is important because, we'll see in my logic below, it has to be a capital Y or a capital N. Capital Y and lowercase y are not the same. So it's important they get it right. And I'm not doing any checking to make sure they enter what's right either. So I'm just reading in, using read line and storing that value into cleaning. Okay? Same thing here. And then same thing here. Now, in my if statement, I'm saying, all right, if cleaning equal capital Y. So that's why it's important that the user enters in a capital Y, because a lowercase y is going to cause us to fail. Because lowercase y is not equal to uppercase y. All right? But one of the important things here I wanted to show you, again, reiterate, is that I can do this with strings. I can use the equality operator to compare a string variable and, in this case, a string literal. Okay? Or I can compare string variables or string literals, any combination. So I can use the equality operator to compare them for equality. All right, so if cleaning is equal to y, and X-ray is equal to y, and filling is equal to y, then I'm going to give the patient a 10% discount. Otherwise, I'm not. Okay? Any questions about that? So again, the big thing there was really comparing the strings, and also the logical operators. Students have a hard time with those logical operators. Oh, yeah, all right, I guess that's it. Any questions? No? All right. Well, sweet. Well, if you have any questions you want me to answer individually, I can do that, but I'm done for now. Lab Friday, and I'll move to loops Monday.